Hey math kids, today we're going to talk about deductive proofs, and let's just jump right in. You've done this on some level throughout the course, but they want us to prove this statement. So what we're going to start with the geometric definition of absolute value, which just says that if we take the absolute value of x, we know that that's going to be greater than 5. Okay? Greater than the absolute value of 5. And so absolute value of 5, we know that that is just 5. And now we can square both sides. And that's going to give us x squared is greater than 25. That ended where we wanted it to, and so we're good to go on that. Now, I feel like I need to explain this top one a little bit more, and so let's just plug in a value. So we pick any value that's less than negative 5. So let's say negative 10 is less than negative 5. And if no matter what, if I take the absolute value of both sides, that's going to be 10 is less than 5. We know that's not going to be true. Now, any number I pick that's less than, if I pick negative 6, negative 7, negative 8, negative 100, all of those are going to make this false unless we flip it and we say that it's greater than. Okay, so hopefully that made sense, why we flipped that and everything. Okay, all right, if you want to discuss it more, we can talk about it in Math Lab. Now we got to this, and part B asks us to prove why the converse is not true. So remember, the converse is if we said that this implies this. Okay, so what we're going to do, we're going to start with this one. And let's just pick a value, because if we can prove even one case that it's not true, then that will work. So let's just choose x equals 7. So that's 49 is greater than 25. That's true. And then that implies that this should be true if the converse is true. And then 7 is less than negative 5. That's not true. So the converse isn't true. Okay, so that's all we have to do on that one. And so if you need additional help, please come to Math Lab. Until then, calculator.